All right, this is a test review for Unit 3, AB Calculus. And I'm going to go over this free response question, and then I'm going to do the free response number 2. Okay, so first we have a piecewise function with missing letters A and B are constants and x is our variable, and the pieces connect at 2. So if A equals -3 and B equals 4, will F be continuous at x equals 2? So to see if it's continuous, we need to see if the piece equals this piece. If A is -3, B is -4, and x is 2. Okay, this is really easy, you guys. This is really easy math. So what we're practicing is proper notation. So did you use the proper notation? Did you say f of 2? That is a loud announcement. Oh my goodness. Okay, so you see A is -3, X is 2, and B is 4, and I plugged it into I want to say the numerator, but that's not correct, the top piece, and we get -2, and plug those numbers into the bottom piece, and we also get -2. You guys, this is a middle school math problem, so what makes it calculus? This makes it calculus, and then justify your answer. So our justification has to come from the definition of continuity, okay? And that was a 3-part definition. And what that means is f of 2 has to equal the limit at 2. Oh my goodness, what a day of noise. F of x is, yes, you have to answer the question. Is it continuous? You have to say yes or no. Yes, f is continuous at 2, x equals 2, because the limit as x approaches 2 of the function equals f of 2. So the limit from the left equals the limit from the right, and they both equal the function. Okay, how do you tell if it's differentiable? Well, step 1 is we have to find the derivative of f. So you should write f prime equals, okay? So, and they gave us a and b, so I plug those in. So f of x equals this. So f prime equals this simple function, yeah? 2 times -3 is -6, x plus 4, the derivative of 2 is 0, derivative of this is -3. Seriously? Can you guys hear those announcements? I don't know if you can or not. It is so loud. Homecoming 2017. All right, do you see what did I do to the derivative? I plugged in 2. Now, in the top piece, I got -8, but then in the bottom piece, there was no x to plug in, so it's just -3. So class, what do you think? Do you think it's differentiable? Did the derivative of the left equal the derivative of the right? No, these are not equal, which means it's not differentiable, and there's the reasoning. And what is this saying? This is saying that the piece on the left has a slope of -8, really steep, but then the piece on the right is a slope of -3, so less steep, so it's at a corner. So the derivatives are not equal. And you have to write it this way. The limit as x approaches 2 from the left of the derivative does not equal the limit as x approaches 2 from the right of the derivative. Okay? Okay, so if it's not differentiable, then you're going to figure out, well, what values of a and b will make it continuous and differentiable at x equals 2. So now forget the fact that a equals -3 and 4. And you guys, this is a process. This is not one step. And this is what your paper should look like, okay? You should have continuous work here, differentiable work here, and then we're going to solve a system of 2 equations. So you get the 2 equations from here, here, and then we solve the system. So is it continuous? Well, you set the top equation equal to the bottom equation, and x is equal to 2, and then we simplify it. This is an interesting video, isn't it? Lights, noise. And we're going to get this to look like this. 2a plus b equals -2. Then we set the derivative equal to each other and plug in 2 for x and simplify this to make it look like this. Now do you see how we have 2 equations with 2 unknowns? So then over here is where I'm solving the system using the elimination method. Once you do that, you should get a equals 2 and b equals -6. Okay, I'm going to go to the back now, and the back was a calculator problem. A rodeo performer spins a lasso in a circle perpendicular to the ground. How exciting! I went to a rodeo when I was in college at Texas Christian University in Fort Worth. The height from the ground of the knot is measured in units of feet. In the lasso is modeled by this function. And that's not good. Okay, got it. Where t is the time measured in seconds after the lasso begins to spin. Find the value of h of 0.75. So this is h, so we're going to plug in 0.75 into the calculator. But you guys, whatever you plug in the calculator, you should write it down what you're doing. Okay. 5 pi over 3 times t is 0.75 plus 5. So we're going to go to the calculator. I wonder if this is going to work on the screen. Oh yeah, I already started a new doc and I have a calculator here. So we have -3 cosine of... Okay, have you used this fraction button yet, you guys? There's a fraction button if above the division. So you hit Control Divide and you get that beautiful fraction. Isn't that cool? 5 pi. I shouldn't say on a video. It's not professional. If you guys take a speech class, you're going to learn how to not say when you speak. In college, everyone has to take a speech class. I took mine at COD. Am I doing okay there? All right, looks good. Okay. So you practice in your own calculator. If you watch me do it, then it doesn't help you. What are the correct units? Well, what are the units of h? H is the height from the ground of the knot, measured in feet. We're going to call this the distraction video. So that's in feet. Okay. And t is measured in seconds after the lasso begins to spin. So the lasso is 7.121 feet off the ground after 0.75 seconds. Okay. Find the value of h prime of 0.75. Okay. So since I'm already in the calculator screen, this is hilarious. That's the wrong bell. Derivative at a point. My value is going to be 0.75, and I have x here, so I want to make sure that when I type it in, I'm typing in x and not t. T's on the paper. So what I'm going to do is I'm going to type this in. Oh, you guys want to know a shortcut? I don't know if this will work. Will it work? Okay. Now they're saying... Okay. Oh, you didn't know what I did. Okay. I went here and I did Control C. What's Control C do? It copies it. And I'm going to paste it in here by doing Control V. And ta-da! It didn't work. Let me try it one more time. Control C. Control V. Nope, didn't work. So what am I going to do? I'm going to type it in, right? -3 cosine, that fraction button we liked, 5 pi over 3. Okay, don't put a number there. We have to put in x. Okay, you have to make sure that x is the variable. Oh, if you don't like that, then you press Control Enter and it turns it into a decimal. Yeah, we don't really like that. We want a decimal. There we go. I did something wrong. What did I do wrong? What did I do wrong? Look at my equation and look what I entered. So the mistake I've made is I forgot to put the +5 at the end of the cosine. Good thing I checked my work. There it is. +5. Oh, why didn't it make a difference? Oh my gosh, this is so cool. This is a lesson. What are we doing? We're taking a derivative, right? And I forgot to put +5 here, and I got scared. Maybe I got the wrong answer. But then I put it +5, and I got the same answer because we're taking a derivative. And what's the derivative of 5? 0. So it didn't affect the answer. Oh my gosh. See how mistakes are awesome? Not going to do good on timing on this video based on all these distractions and tangents that I'm going on. You get it? Tangents. Okay. What are the correct units? Well, the correct units are the units of h, which is feet, divided by the units of your variable here, which is t, and that's in seconds. So feet per second. Using the correct units, explain what this value represents in the context of the problem. Okay, so this is the rate that the lasso is moving. It's moving down because it's a negative at 0.75 seconds. Okay, so what this means is that a cowboy has a lasso and he's swinging it and it's moving down, and then after it moves down it goes back up like that. So the lasso is moving up and down like that. Okay, so because it's negative, feet is height off the ground. Find h prime of t. Hey, you always try and find a derivative by hand if you can. So the derivative of -3 cosine, what's the derivative of cosine? Negative sine, right? So I'm going to make this positive sine. The inside stays the same. And then I'm going to multiply by the derivative of the inside, which would be 5 pi over 3. And the derivative of that 5 on the end is 0. Now, how can this simplify? Do you see the 3 in the numerator, the 3 in the denominator? So those divide out, and this is really 5 pi times the sine of 5 pi over 3t. Find the derivative and sketch the graph on the axis to the right for the intervals from 0 to 5. All right, we're going to go to our calculator. Oh, but I hope I have enough time. We'll see. I'm going to do Control I to insert a graph, and I'm going to type this in. So I have 5 pi, my pi go, times sine, and I'm going to use that fraction button again, 5 pi over 3. T, I can't use t because the graph, it says x, so I'm going to use x, okay? And, oh dear, that's just way too crazy, and I only need it from 0 to 5, so I'm going to zoom in over here and press enter, and I'm at 0 to 7.5. So I'm actually going to go to Window Settings, and I'm going to make my X minimum -0.5 and my X max 5.5. Okay, that's crazy. How am I supposed to graph that? I wonder if I did something wrong. That's what I wonder, you know, and it's just that crazy. Okay, so we need to graph this somehow, but let's try and answer the questions. Do you want to see my graph? Ready? Ta-da! It's a graph. I hope I haven't made a mistake. I'll check my work before the video's over. During the first 5 seconds of the performer spinning the lasso, how many times is the lasso at a max height? Max height means you go from, the derivative goes from positive to negative. So how many times did it cross from positive to negative? 1, 2, 3, 4. 4 times. 4 times. Give a reason. That's where the derivative passes from positive to negative. What's the height of the lasso the first time it's at a maximum height? Okay, I'm going to answer this. I'm going to pause and answer it. Okay, I went back and checked my work. It's all good. Our derivative is correct. My graph is beautiful, isn't it? I used trace to find these points, and it crosses 4 times. The derivative changes from positive to negative. Okay, the first time, oh, I did this wrong. Shoot, hold on. Okay, what I did was I found the maximum height. So the first time it reaches the minimum height is at this point here when it goes from negative to positive, the derivative, which is 1.2. So 2.